Right. I'm not at all sure how this is gonna work. I'm sitting on the floor. I'm trying to chaperone a sick cat back there. He's not feeling well. Took him to the vet yesterday, and so he's like set up in this room with his own litter box and stuff. They don't know what's wrong. We're hoping he gets better, but he's old. So I'm sitting on the floor, just kind of chaperoning my cat, keeping him company so he doesn't feel like he's been bad, because he hasn't been bad. He's just feeling sick. And I'm going to try to demonstrate what I want you to do with these cams. So last year we did this in Fusion, and students were supposed to use the measure tool in Fusion, and it ended up being very, very awkward to do. And so I physically printed a bunch of cams out because it was easier to like put your hands on the cam and like use a ruler and get the measurements you want. But with so many students, so many groups and stuff, that's not a feasible way to do it this year. So what I am going to do is I'm going to hand you just like a paper that looks like this, that's got like a cam on it, and you're going to use a ruler to generate the numbers for your graph. But I wanted to demonstrate like what it is I want you to do. So there is going to be some estimation involved here, and that'll be okay. This isn't a math class where everything has to be like accurate and you're not allowed to, change square roots to decimals and stuff. We want like function here. And so here's what I want you to do. You are going to define, first of all, you're going to need the center of your circle. And like mine is, I don't know the best way to do this. I think I made a little dot there. I've got like my computer propped up on a cat carrier. Let me try to do it with my hand. Like the center of the circle. Okay. And for those of you that are in Algebra 2, I know that this dovetails really well with those of you in honors anyway that are doing the trigonometry right now. Standard doesn't quite get to this. We get to a little bit of trig at the very end of the year, but you're going to generate a graph, okay? And this one is we're just going to use the first quadrant, okay? And on the x-axis, you're going to have degrees is what you're going to measure. Now, typically in a math class, you would use radians. There, I usually introduce it in degrees because that's what students are familiar with coming out of geometry. And then in Algebra 2 or pre-calculus, you learn about radians. And so you usually see radians. But we're going to do it with degrees, and you're going to have 0 degrees, and then 45 degrees, then 90, and you're going to go all the way up. I'll use like a dot, 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 like up to 360. Okay, so obviously that is not to scale. So, and you're going to measure the displacement every 45 degrees. Now, the way this works, so if you were building a cam, or your automata, your follower is going to sit right on top of the cam. And what we're looking for is how that follower is displaced as the cam like rotates. So I want you to define 0 degrees as the orientation of your cam with the smallest displacement, which is going to be this view right here. And you're going to take a ruler and measure that distance right there. Okay. And I mean, I don't know what that is. You are welcome to use either inches or centimeters or millimeters. I will let you choose the unit. But let's just say like I use centimeters. Okay. And so my y-axis is the displacement, sorry about that, is the displacement of the follower in centimeters. And so I get my measurement, and let's say my measurement is right there. Okay, whatever that is. So whatever that distance is. Then what I want you to do is go out in 45-degree increments. Okay, from there. So as you rotate, and I'll let you decide like which way you want to rotate this, because it's probably easiest to like physically turn the cam so that you're going to turn it, and then you would label like 45 degrees like right there and measure that distance. But on the screen that looks and feels kind of backwards. But again, for those of you that are in that are doing like your unit circle right now, because this is essentially the same thing, this would be your 0 degrees, and then your 45 degrees is going what we call yeah, counterclockwise, and then 90 degrees is counterclockwise, and then you have like 135, 180, 225, like a little blank there, 270, and then like so forth, and then 360 brings you back to the 0. So this would be going the same direction that counterclockwise. So you'd actually take a protractor and measure the distance there, and that should be a little bit bigger because you're going at an angle. Now, unlike the unit circle, I'm not going to make you put a right triangle in there, but you'll label that point. Then you're going to go 90, okay? And notice that this is a 90-degree angle right there, okay? And you'll measure that distance. And then you'll do 135, okay? Like something like that. And then 180 is going to be the exact opposite direction from your 0, okay, just like it is on the unit circle. So you have 0 degrees and you have 180 degrees, and they're opposite each other. So in this particular cam here, like the 180 should be in the opposite direction, and that should be your maximum displacement. And then you're going to keep going, okay? And what you should end up with is something that looks, well, that's like wrong because because it's wrong, but it's because I have like the wrong numbers on there. But it should max out at the 180 and then come back down, and it will resemble a sine wave. So for those of you in Algebra 2, it should resemble that because it's got a similar kind of relationship there. Just we're dealing with the center being like off. It's like not in the middle of the circle. Like the center of rotation is not the middle of the circle that we have there. So it is kind of a neat twist on that. But when you plot that displacement, it should end up reminding you and looking like a sine wave because that math transfers over. What's interesting to do, and what the original PLTW curriculum would have you do, is it would have different groups pick different styles of CAM and then repeat that process. So if any of you are interested in some extra credit, at least this year, I'm like totally open to you doing that, where you would do something like this, and then you'd go out at the different angles and measure it and generate what that relationship would look like. And you can do the same thing with like a pair. Well, that's not a pair cam. I don't like that's, I mean, I don't know what it is, but it wasn't a pair, but like a pair. Try again. Like, well, that looks more like a nose cam, which isn't a thing, but I mean, it could be a thing. And then you would define your angles and measure them, measure that distance out. But for the purposes of a class activity, the simplest one to start off with is that eccentric cam. It's just the most straightforward shape that we have. And the more measurements you can take, the more accurate your graph will be. So that really corresponds to some stuff from math class as well. The more data you have, the better the sense of the shape of what that graph will be. So if you are interested in some extra credit, what I will do is I will give you a different shape cam and you'll repeat the process with this other shape cam. So I wanted to make sure that I had a demo video for what we were going for in this particular activity, and you can refer back to this if you need to and you kind of fall behind in class and you need to do some catch up. So I hope this helps. Please let me know if you have questions and we'll take it from there.